Hello, I'll be going to talk about on probabilistical graphical models and give a glimpse about exact and the approximate inference in probabilistical graphical models used for scene and object recognition. So let us talk about what is graphical models. So what are graphical models? Mm, A graphical model is a probabilistical model for which graph denotes the conditional dependency structure between the random variables. For the graphical models are divided into two types: directed graphical models and undirected graphical models. Directed graphical models are known as Bayesian networks, which are directed acyclic graphs, and undirected acyclic graphs include Markov random fields. The example of the Bayesian network can be shown in this diagram, which is it is a directed acyclic graph, and nodes represent the random variables, and edges represent the direct influence. For example, radio has a direct influence caused by the earthquake, and alarm has a direct influence caused by the earthquake and the burglary, and the call has a direct influence caused by the alarm. So the joint probability distribution of burglary, earthquake, alarm, radio, call can be stated as the probability of burglary into probability of earthquake given burglary into probability of alarm given burglary and earthquake into probability of radio given earthquake, burglary and alarm, and into probability of call given radio, alarm, burglary, earthquake, which can when we simplify this equation, we will get a probability of burglary into probability of earthquake into probability of alarm given burglary and earthquake into probability of radio given earthquake into probability of call given alarm. The second example of the Bayesian networks, which is also a directed acyclic graph, which is known as hidden Markov model, in which x1 and x2, x3 are the hidden states, and y1, y2, y3 are observations, and joint probability distribution of x, y can be stated as probability of x1 into probability of y1 given x1 into probability of x2 given x1 into probability of y2 given x2, and so on. The second type of the graphical models which I stated is the Markov random fields, which is undirected graph, and each click C has a potential function psi. Since x3 has a direct influence caused by the x1 and x2, so we have one psi, which is psi of 1, 2, 3. Similarly, x4 has a direct influence caused by x3, so we have psi of 3, 4. And x5 has direct influence caused by x3, so we have psi of 3, 5. So probability of x1 to x5 can be stated as 1 upon z, where z is a normalization constant, into psi of 1, 2, 3 into psi of 3, 4 into psi of 3, 5. The normalization constant z can be stated as a summation of x1 to 5 into psi of 1, 2, 3 into psi of 3, 4 into psi of 3, 5. Potential for Markov random fields. One potential per maximal click. As I said before, since x3 has the direct influence caused by x1 and x2, so we have psi of 1, 2, 3. Similarly, we have psi of 3, 4 and psi of 3, 5. In one potential per edge, every edge has its own potential. For example, x1 and x2 has its potential psi of 1, 2. Similarly, x1 and x3 has its potential psi of 1, 3, and so on, psi of 2, 3, psi of 3, 4 and psi of 3, 5. It can be stated as for one potential per maximal click, potential of 1, 2, 3, 4, 5 is directly proportional to psi of 1, 2, 3 into psi of 3, 4 into psi of 3, 5. In this, probability of 1, 2, 3, 4, 5 is directly proportional to psi of 1, 2 into psi of 1, 3 into psi of 2, 3 into psi of 3, 4 into psi of 3, 5. Directed versus undirected models. In directed models, we know the directed model is Bayesian networks, in which this graph can be stated as a probability of 1 into probability of 2 into probability of 3 given 1 and 1, 2 into probability of 4 given 3 into probability of 5 given 3. In undirected models, which is Markov random fields or Markov networks, we have 1 upon z, where z is a normalization constant, into psi of 1, 2, 3 into psi of 3, 4 into psi of 3, 5. The factors graph are of three types: Bayesian network, Markov network, and pairwise Markov network. In Bayesian networks, as we stated earlier, this Bayesian network can be stated as probability of 1 into probability of 2 into probability of 3 given 1 comma 2 into probability of 4 given 3 into probability of 5 given 3. In Markov network, we have 1 upon z. Again, the normalization constant into psi of 1 2 3 into psi of 3 4 into psi of 3 5. And in pairwise Markov network, as we stated earlier, every edge has its own potential. So we have 1 upon z into psi of 1 2 into psi of 1 3 into psi of 2 3 into psi of 3 4 into psi of 3 5. So we talked about graphical models, and now we will talk about inference. What is inference? Because the Bayesian network is complete model for the variables and the relationship can be used to answer probabilistical queries about them. For example, the network can be used to find out the updated knowledge of the state of a subset of variables when other variables are observed. This process of computing the posterior distribution of the variable given the evidence is known as probabilistical inference. The inference can be also known as state estimation. One of the inference is Bayesian inference. Sometimes which is Bayesian inference has its application in speech recognition, image processing, information coding, medical diagnosis, fault diagnosis, and in biology and many other fields, which is one of the most important inference. Sometimes it is easier to specify probability of effect given cause than to specify probability of cause given effect. We can use the Bayesian rule to state that probability of disease given symptoms is equal to probability of symptoms given disease into probability of disease divided by summation of all the possible combination of diseases of probability of symptoms given disease into probability of that disease. Decision theory. The decision theory is a combination of probability theory and utility theory. Bayesian networks plus utilities is equal to influence or decision diagrams. Maximize the expected utility is we have to maximize the expected utility to gain the high performance, which can be stated as A star is equal to argmax of A summation of all the possible combination of X, joint probability distribution of joint utility distribution of X comma A into probability of X given E, where E is the evidence and A is the utility. This the most common type of the inference, which is are exact in inference, and in exact inference the most common type is variable or bucket elimination. In variable or bucket elimination, variable elimination which eliminates the non-observed non-query variables one by distributing the sum over the product. The second type of the exact inference is belief propagation algorithm, which is also known as message passing algorithm. Calculate the marginal distribution for each observed node condition on any previous observed node, and this belief propagation algorithm, also known as forward and backward algorithm. And this belief propagation algorithm is done by absorbing the message and sending the messages, and also includes the factor graph as I described earlier, which includes Bayesian networks, Markov networks, and pairwise Markov networks. Another type of the exact inference is junction tree inference, or can be stated as clique inference, which state that clique tree propagation which caches the computation so that many variables can be queried at one time and the new evidence can be propagated quickly. So we talk about inference. What is inference, and what are the different types of the exact inference? This exact inference have their utter importance in scene and object recognition, especially in the field of the robotics and in the field of the image classification, image processing, speech recognition, And we also and earlier we talked about graphical models which are of two types, Markov networks and Bayesian networks. Bayesian networks are directed acyclic graph, whereas Markov networks are undirected cyclic graph. This two type of the networks are have their utter importance in the field of the artificial intelligence, especially in the domain of machine learning, natural language processing, bioinformatics, neuroscience, etc. So in this PPT we have talked about probabilistical graphical models and some of their applications using exact inference, and we also talk about different type of the exact inference, which include belief propagation algorithm, message passing algorithm, uh, and click tree algorithm, and variable and the bucket elimination algorithm. Thank you.